Hi everybody, Mrs. Pesic here. I am live with Block 4. Block 4, do you want to give a shout out? All right, so we are looking at Section 1.4, Intro to Functions. These are your learning objectives. Determine whether relations between two variables are functions. Use function notation and evaluate functions. Find domains of functions. Use functions to model and solve real-life problems. And evaluate difference quotients. All right, so first up. A relation is any mapping or correspondence between two sets. So we're not even using the word function yet. All right? We are using the word relation as any mapping between two sets of numbers. Usually we call it the first set of input, and it's going to some numbers in the output. So in my first example, I got 1 going to 2, 3 going to 7, 5 going to 7. This is called a mapping diagram. That's what we call these. I got another example where 5 goes to 7, 1 goes to -4, and 1 goes to 2. These are both examples of relations, all right? And we're demonstrating these with a mapping diagram, all right? So I don't want you to copy this definition down. I just want you to look and listen for right now. A function, f, from set A to set B, is a relation that assigns to each element x in set A exactly one element in set B. You do not need to write that down, but I do need you to wrap your head around that. And that means that one of these relations qualifies as a function, and one of them does not. Which one of these is not going to be a function? Gina. Why the one on the right? All right, we can't have one number in the input going to two different numbers in the output. So these are both relations, right? They're both good relations, but this one is not a function, not a, I'm abbreviating, not a function. This one is, yes, a function, right? Because here, 1 goes to 2 and only goes to 2. 3 goes to 7, 3 doesn't go anywhere else, it only goes to 7. And 5 goes to 7, 5 only goes to 7, it goes nowhere else. All right, it's okay if 2 of my inputs go to the same output, but I can't have one input going to 2 different outputs. Are we okay with this? All right, that's the nitty-gritty of what a function is. The set of inputs is called the domain, and the set of outputs is called the range. Have you heard of these words before? Yeah. Of course you have. All right, so there are 4 ways to represent a function. You can represent a function verbally with a sentence description. You can represent a function numerically with a table or a list of ordered pairs. You can represent a function graphically. And you can represent a function algebraically, all right, with an equation and 2 variables. So, for example, my sentence description, let's see, my sentence description could be something like, let's see, the output is 2 times the input, all right? That would be, you know, a sentence description, like I'll put that like that's a verbal description of a function, right? The output is always going to be 2 times the input. Numerically would be a table or list of ordered pairs. So if I go along with that same sentence that I have, numerically I could say, oh, well, if x is 1, then y is going to be 2. If x is 3, y is going to be 6. If x is -4, y is going to be -8, right? Because here's my table that corresponds to the output is 2 times the input. Everybody with me? I could graphically show this, so I could make a little chart and plot, you know, 1, 2 is right here, 3, 6 is right here, -4, right? And I could just plot points to represent it. That's graphically. Or algebraically would be writing it as an equation in 2 variables, and that's me writing y equals 2x. So this is the algebraic way, this is the graphical way, this is the numerical way, this is the verbal way. Everybody with me? 4 different ways. Oh.
So is there something?
Vertical line test? Yes, I think we're going to get to that. But yeah, that would correspond with like this, if we were going to plot these points, you know, one, 1, -4 would be here, and 1, 2 would be here, and a vertical line would, a vertical line test would fail. Yes, they remember that. Okay, so which of these would be a good vending machine? Which of these would you want to put money in? Well, this one, you could get Coke or Diet Coke, right? If you like Coke, you'd probably put your money in B, right? If you are a gambler, maybe you would choose vending machine C, because you would just push the one button and you would not know what you're going to get out. Agreed? So these two would kind of represent functions, and this one would not be a function, right? Because I push one, I might get Coke, or I push one, I might get Diet Coke. All right. So if we have a function written as an equation, then x is the independent variable and y is the dependent variable. All right, and we have this example: determine whether x squared plus y squared equals 8 represents y as a function of x. How do we do that? We just need to solve this equation for y and see if we can write it as a function of x. So to solve this for y, what should be the first thing I do to solve this for y? Scott?
You could square root both sides.
Before we square root.
You could take away x squared.
All right, so let's subtract x squared from both sides. So I get y squared equaling 8 minus x squared. Then what would be our next step, Antonio?
Then you could square it.
Take the square root. What do we need to remember when we take the square root of both sides, Kaylee?
We have the y would equal, or both plus or minus.
Plus or minus. So here we're getting y equals plus or minus the square root of 8 minus x squared. This plus or minus right here is the kiss of death for a function. Because this means if I pick, let's say I pick a point like 1 for my x, I plug in 1, I get 8 minus 1 squared is 7, square root is 7, but I could have positive 7, or I could have 1 going to negative 7. Would you agree with that? You can't have that and have this be a function. So determine whether this equation represents y as a function of x. That's a big no, and again, it's because of the plus minus. We could also think about the graph. What's the graph of x squared plus y squared equals 8 going to look like? I should see all of your hands up in the air because you just did the homework last night. So x squared plus y squared equals 8 would be what kind of a graph?
Parabola? It would be like a sideways parabola.
Oh, it would be like the origin.
Would be origin where?
Oh, it'd be the one with the origin.
Mallory?
Wouldn't it be a circle?
It would be a circle, right? And it would be a circle centered at the origin, right? It'd be a circle centered at the origin, and it would happen to have a radius of square root of 8, right? Like 2.9 something, right? Is a circle going to pass a vertical line test? No. So that's another way to test that this is not going to be a function in terms of x. All right, let's talk about function notation. Okay? All right, I'll take hats back. And you guys are going to watch videos and check the homework assignment. All right? Okay, so f can be the name of a function. You don't have to use f of x. You could use g of x, or h of x, or p of x, or q of x, whatever you want. For example, y equals 5 plus 3x can be rewritten f of x equals 5 plus 3x. The input would be the x. The output will be f of x, and the equation is f of x equals 5 plus 3x. When we see f, left parentheses, x, right parentheses, that's red, f of x. Okay? And f is just the name of the function. F of x corresponds to the y value for a given x. All right? So in this case, if I write f of -5, That's a faster way of writing, I'm looking for the value of y when x equals -5. That's a lot to write or say. So mathematicians are notorious for wanting to shorten things, condense things, give symbols to represent things. So add left parentheses -5, right parentheses means find the value of y when x equals -5. All right. So in this case, if we wanted to find f of -5 from my example, we would just do 5 plus 3 times -5 and get, what's that going to be? -10? Does that look right? All right, so a little practice. I got a new function for you. F of x equals 3x squared minus 7x. So what's f of -5 going to be in this example, Georgina? Talk me through this.
Okay, so it would be f of -5 equals 3 times, or 3 parentheses, -5 squared minus 7 parentheses 5.
-5?
-5.
All right, so you could do this on your calculator or by hand. We have to do the squaring first, order of operations, and we positive 25 times 3 is 75. Is that plus 35?
Yeah.
Are we getting 110? Look okay? All right. You get the idea. We could do f of 2, but I'm more interested in what are you going to say for f of $sign? What's a f of $sign going to be? Abigail.
Equals 3 times $9 squared minus
Times $sign?
Yeah.
Everybody agree? Whatever's in this parentheses, you're going to plug in for x. The x comes out, and that goes in. Everybody with me? So you can use other letters, as I mentioned, other than f. You can use g. So let's say I got g of x equaling 10 minus 3x squared plus 5x. Can you help me out? What's g of x plus 2 going to be? Allie Beth.
x plus 2 is going to be,
G of x plus 2?
oh, g of x plus 2, sorry. It's going to be 10 minus 3, in parentheses, x plus 2 squared plus 5 times x plus 2.
Everybody agree? And if we were going to simplify this, we would have to, we'd have to do x plus 2 times x plus 2 using FOIL. That's 2x, another 2, that's 4x plus 4. We'd have to distribute that. We got 10 minus 3 times this. We have, you know what I mean? You get the idea, right? To simplify. Okay, moving on. Okay. Nice meeting you, Peggy. All right, a function defined by 2 or more equations over a specified domain is called a piecewise function. Ever hear of it? Yeah. Thanks to our first quarter project, you guys are all over piecewise functions as well. So here's an example of a piecewise function. F of x equals 3x minus 4 if x is less than 0, and f of x equals 3x plus 1 if x is greater than or equal to 0. So I'm asking you to evaluate this function when x equals -2, 0, and 2. In other words, I'm looking for what is f of 2, what's f of 0, and what is f of 2. All right, so a little help. How are we going to find f of -2? John.
So for the first equation, it would be 3 times -2 minus 4.
Okay, are you going to plug it into the other one also, or just that one?
Both.
Both of them? People agree? Plug it into both? Georgina?
I disagree, because -2 is not greater than 0.
So you're saying you got to look at this -2 and then decide which one to plug it into? So John plugged into the first one, so stick with that. All right, so we only want one answer, right? We don't want to plug -2 into both, because then we'll get 2 answers. Do we want -2 going into a function and getting 2 different answers as our output? No, every input can only have one output. So I'll go with what John told me so far, -6 times 4, is that -10? Is this okay? All right, what's f of 0 going to be, Jane?
It's going to be
plugging it into the second equation?
Yeah.
Why is that?
Because the second equation is x is greater than or equal to 0.
Greater than or equal to 0, so we gotta go with equation 2, and so 3 times 0 plus 1 is just 1. Does that look okay? All right, what about f of 2, Brian?
You would plug in, so f of 2 equals 3 times 2 plus 1.
You're plugging it into the second equation? Because 2 is greater than or equal to 0? And we're getting 7. Are we okay with this? All right. Okay, let's talk about domain. The domain of the function, and you guys are all over domain of functions. That was one of your summer Blackboard quizzes, right? You did a whole thing about domain. Plus, we talked about domain again in section 8.1, 8.2. I can't remember which one now. So we've already talked about it. We're going to talk about it a little bit more now. It's a very important concept for Algebra 2. The domain of the function can be described explicitly, or it can be implied by the expression used to define the function. If I'm going to define the domain explicitly, that would be like if I said, you know, I want f of x to be x squared, but I only want it for x greater than or equal to 0. I'm defining, I'm giving explicit, right, definition of my domain. Right? I'm explicitly defining my domain. All right, so, but now, what about an implied domain? Well, that's when we have to do with the things that we looked at in section 8.2, the things we talked about in the summer video. So, what would be the implied domain for G of R? That's what really, like, what are the only values I'm allowed to plug in? Are there any values I'm not allowed to plug in? Braylon?
So if we R can't equal 3 or 3.
All right, R cannot equal 3, R cannot equal negative 3. Everybody agree with that? All right, that would be the implied domain. All real numbers are good except 3 and negative 3. What about the implied domain for my h of t function? Kyla. T cannot equal 3. Why is that?
3 minus 0, 0, 0.
So isn't it allowed? Aren't we allowed to take the square root of 0? You just said square root of 0, 0. So I think 3 is okay, but I think there are problems. There are some numbers that we're going to have to exclude from our domain. What are we not allowed to have underneath of that?
All negative.
Can't have negative numbers, right? So
anything less than
anything less than 3 you're going to keep, or anything less than 3 you're going to take out. Okay, yeah, because we want t minus 3 to be greater than or equal to 0. So if I add 3 to both sides, I get t is greater than or equal to t is greater than or equal to 3. And that means really this one, if we were going to use integral notation, we could say 3 constant would be the domain. Antonio.
Wouldn't it be less than?
The values that we're keeping or the values we're kicking out?
Oh, I was kicking it.
Oh, no. I didn't say not equal to. I said here's our domain.
Okay.
Are we okay with this? All right. That's a little reminder about domain. Let's take a look at this application problem. For a cone, the ratio of its height to its radius is 3. Express the volume of the cone. V equals 1/3 pi r squared h. That's the formula for the volume of any kind of cone that you might see. But we want to express the volume as a function of the radius. If you see a problem like this, express the volume as a function of the radius, that means we need to get rid of this h. We don't want to have an h in here. We want the whole equation just in terms of r. All right? So in this case, we got to go back to, they gave a hint about this particular cone. The ratio of its height to its radius is 3. So that would be h over r has to equal 3. Right? And if I'm looking for a way to get rid of this h right here and write it somehow in terms of r, how could I express h in terms of r if I have this equation to work with? A little help. Jasmine. I want an expression for h in terms of r. Can you take this equation and write it so h is by itself? All right, if I multiply both sides by
Or, I mean, R.
by r. If I multiply both sides by r, the r's here divide out and I get h equals 3r. That means for this problem, I could replace this h with 3r. So it means I can write v equals 1/3 pi times radius squared times 3r. Now I've written this as a function of the radius. I can even write it as v of r, right? Instead of f of x, I could write v of r equals 1/3 pi. I can clean this up, couldn't I? What could I write this as? If I was going to clean this up, how could I write this, Ellie?
Would it be pi over 3?
Pi.
No, it would just be 1/3 times pi, so, right?
Yeah, but I got r squared, I got an r, I got a 1/3, I got a 3. How can I clean that up?
Well, I would just multiply them
All right, so what's 1/3 times 3?
times 3.
Oh, 1. So I get 1 pi, and how many r's do I get multiplied together? It's going to be r to what power? The third. So I really could write my function as v of r equals pi r cubed. Are we okay with this? All right. So in this problem, it says in country A, I'm not naming the country, I'm making this up. In country A, if you earn $50,000 or less, you pay 18% tax to the government. If you earn more than $50,000, you pay 23% in tax to the government. So write the piecewise function that gives the tax if you enter the income. All right. Take a minute. Talk about this in your pods. How are you going to write this as a piecewise function? We want to know. We want to enter the income as x, and we want f of x, the output, to be your tax. But it's going to have to be a piecewise function because there's two different rules depending on how much money you make, right? So talk about it in your pods. How are you going to write this? And while you're debating, I'm coming around to gather hats. Can you count them off your calculators?
Those actual functions. The part where it's like excess.
Anybody got any thoughts so far?
I just, I know that like for the one part it would be like x is the greater than 1.
All right, so Ellie says that part of it has to be, x less than or equal, is that right? If you're 50,000 or less, so x less than or equal to 50,000, right? And then what's the other one going to be?
X greater than 50. Yeah. Or just x greater.
I think just greater than 50,000. Everybody agree? So now you got to come up with what's your function to go along with those limiting pieces, right? All right, so we got this. How are we going to get the tax? If we want 18% of a number, how do we get 18% of a number? Antonio. 0.18 x. Do people agree with 0.18x? Yes? All right, so I think that we want our function to be 0.18x if x is less than or equal to 50,000. And then what's the other one going to be? Yeah, 0.23x if x is greater than 50,000. All right, test out your function. Now that you've got it, and find f of 40,000, f of 50,000, f of 51,000. All right, little help. What'd you get for f of 40,000? You make $40,000 in country A, and you end up paying how much? Brooke, what'd you get?
7,200.
All right, $7,200. Everybody agree? All right, what if you make $50,000? What are you going to be paying, Haley?
$9,000.
9,000. Do people agree with that? What if you're making $51,000? Then you're going to pay how much here, Courtney? 11,730. Do people agree with that? Wow, you make $1,000 more dollars. You owe 2,730 more in taxes. Does that sound fair? Does not sound fair. All right, let's take a look at difference quotients. Difference quotients are used in calculus, and actually I think this would be a good spot to stop. All right, so this is really our last page, so I'm going to make a little video about difference quotients for you to look at as part of your homework, because that is our last page of our notes, is on difference quotients. All right, so hey everybody, thanks for watching. Have a great day.